Hello everyone, my name is Jibril Anifowoshe. Thank you for joining me today on my practicum in business intelligence presentation. As part of the introduction, I'd like to provide an overview and objectives of the business problem and challenge addressed. Our proposed business intelligence practicum project addresses a pivotal challenge encountered within the restaurant industry. Our main goal is enhancing supply chain resilience, and we aim to solve a business problem. Essentially, how can data demand forecasting insights altogether contribute to bolstering supply chain resilience within the restaurant industry? We think that by embracing advanced demand forecasting techniques and data-driven insight, this project will facilitate restaurants with the tools to make proactive decisions, improve inventory management, and promote trends that are pivotal to sustained growth. To break it all down, we would essentially explore how leveraging data-driven insight can enhance supply chain resilience in the restaurant industry. Within our integrated data set, you would see that we have utilized several chains in order to make our project relatable and useful to majority of the restaurant chains, if not all of them. Without further ado, let's delve into the data collection and preparation efforts. For the data collection and preparation, we will basically describe the data sources used for the analysis, and we will also discuss the process of data cleaning, integration, and transformation. Our data collection and preparation steps showcase the development of an integrated restaurant dataset utilizing reports from Touch Bistro and Extensive, along with data from Kaggle, ERS, USD.gov, and synthetic supply chain data. The aim is to enhance supply chain resilience in the restaurant industry through comprehensive insight. The process involved extracting, consolidating, and transforming data from various sources, including restaurant chain information, CPI, PPI forecast, customer satisfaction data, and simulated supply chain element. The techniques used include data structuring with Python's Panda library and integration of various data sets to reflect real-world scenario. All of the data set in questions that were integrated are top 100 chains, which was retrieved via Kaggle and provided a base restaurant data, including chain names, segments, menu categories, sales, units, and year-over-year changes. The CPI forecast and the PPI forecast was retrieved via ERS USD, which offered forecasts of the consumer price index and the producer price index, which were integrated into the base restaurant data. The TripAdvisor restaurant recommendation was retrieved via Kaggle, and it contained customer satisfaction data, specifically overall ratings from TripAdvisor. The next part of our presentation is to explore the data analysis and visualization aspect of the project. We will present the analytical techniques and tools employed and showcase the key findings and insights derived from the data analysis. After that, we will demonstrate effective data visualization techniques that were utilized to communicate the result, and with the aid of Tableau, which is a BI cloud solution, will help us to explain how visualization contribute to a better understanding of the data. So, we first conducted EDA, which is exploratory data analysis, to understand the data even better. We utilize Python to essentially comb through our data to see what's hidden and what can be emphasized on. We imported several libraries that will be needed for our plotting and analysis. We started by loading the data, integrated restaurant data from reputable sources, as mentioned earlier. We explored its structure, generating summaries, statistics, and visualizing the data distribution. The goal is to identify any potential outlier and observe interesting patterns, trends, or anomalies. Here we display the summary statistics for all the columns. We visualize the data distribution using histograms. We then use box and scatter plots to identify potential outliers and relationships for key numeric columns. We finally visualize correlation using heat maps. To break it even further, the histogram provides us an understanding of the distribution of the data. Skewed distribution might need transformation for certain types of analysis. So for example, if the data forms a bell-shaped curve, it can be considered normally distributed. The box plots help in visualizing potential outliers. Data points outside the whiskers can be considered outliers. The box basically represent the inner quartile range where the 50% of the data lies, and the line inside the box represent the median of the data. The scatter plots give a visual understanding of the relationship between pairs of numerical columns. A positive slope in the scatter plot suggests a positive correlation. Likewise, a negative slope suggests a negative correlation. The scatter plot without any clear pattern would suggest a weak or no correlation between the variables. And finally, the heat map provides a numeric measure of linear relationship between columns. As you can see, values close to 1 or -1 essentially indicate strong positive or negative correlations, respectively. In like manner, coefficient close to 0 would suggest a weak or no correlation. To provide a short recap of our EDA that we utilize Python, one can see that there are unique about 100 distinct restaurant chains that were represented. Their chain name, segment, menu category, and as far as the segment is concerned, there are at least 7 unique segments. With the menu category, there are up to 20 unique menu categories. There are information about supply lead time, inventory levels, supply reliability, deliver person's age, and relationship with their ratings. More importantly, there are some aspects that could prove to be an outlier that we could potentially explore further. So for example, there might be suggestions some delivery personnel have received notably lower ratings than others, maybe due to their age, distance, or whatnot. These are elements that could be further looked into. Furthermore, given our understanding of the analysis, we then formulated 4 questions and hypotheses that we utilized Tableau to help in answering and visualizing. Note, as part of this video, a link to a publicly available Tableau dashboard has been provided to you to follow along and interact with the dashboard. So, after loading our data into Tableau, our first visualization is to look at the impact of restaurant segment on US sales. The question is, does the restaurant segment like quick service, casual dining, and the rest influence the US sales? Our number one hypothesis is looking at premium segment like fine dining might have higher US sales compared to quick service due to the price point of items on their menu. The explanation showed on the Tableau is that the average US sales differ across restaurant segments. For instance, the average sales for the fine dining are approximately $429 million, while that for quick service is approximately $4,020 million. This observation suggests that quick service segments have considerably higher US sales compared to fine dining, which is contradicting to our initial hypothesis. Secondly, we wanted to look at the effect of delivery person's age on their ratings. The question is there a correlation between the age of the delivery person and their ratings? Our hypothesis states experience might play a role in customer satisfaction, so older delivery personnel could have higher ratings. The answer, however, is that given the negative correlation value, the accurate interpretation should be the correlation value between the delivery person's age and their ratings is approximately negative 0.1. A negative correlation indicates that as the age of the delivery person increases, their ratings tend to decrease. This observation suggests that, contrary to our hypothesis, older delivery personnel might not necessarily have higher ratings. The negative correlation value contradicts the initial hypothesis that older delivery personnel would have higher ratings due to experience. Thirdly, we wanted to look at the influence of supplier reliability on inventory level. The question is, how does supplier reliability impact the inventory level at restaurants? Hypothesis states restaurants with more reliable supplier might maintain lower inventory levels due to consistent and timely supply. The correlation value between supplier reliability and inventory level is approximately 0.05. A positive, though weak, correlation value indicates that as supplier reliability increases, the inventory level might also slightly increase. This observation suggests that the data does not strongly support our hypothesis that the restaurant with more reliable suppliers maintain lower inventory level, but it's still a positive. And lastly, we wanted to explore the relationship between US sales and the number of units. The question is there a correlation between the US sales of a restaurant chain and the number of its units and outlets? The hypothesis states restaurant chains with higher US sales might have more outlets. The correlation value between the US sales and the number of units is approximately 0.48. A positive correlation, and would suggest that as US sales increases, the number of outlets tends to increase as well. These observations support the hypothesis that chains with higher sales tend to have more outlets. So, in conclusion, our EDA, backed by the power of Tableau, has paved the way for data-driven decisions. It's a testament to the fact that when data meets the right tool and inquisitive mind, it can lead to transformative insights that can redefine strategies, drive efficiencies, and even create a competitive edge. To bring it home, we wanted to discuss the business impact, challenges and limitation that was faced during the analysis, and future recommendation, as well as a holistic recap of everything that we've discussed and displayed thus far. The impact of restaurant segments on US sales. Within the analysis revealed that quick service restaurants have significantly higher US sales compared to fine dining. This would suggest a market preference for quick, affordable dining option. The quick service segment does represent a larger market share and higher revenue potential. The recommended action is to consider expansion in quick service sector and explore marketing strategies to enhance the appeal of fine dining. Secondly, looking at the effect of delivery person's age on their ratings. The data shows a negative correlation between the age of delivery personnel and their ratings, indicating that younger staff may be more effective in meeting customer expectations, possibly due to their greater agility or tech savviness. recommended action is to implement training program for older staff members and maintain a diverse age range in the hiring process. Thirdly, the influence of supplier reliability on inventory level. There is a weak positive correlation between supplier reliability and inventory levels, suggesting that factors other than supplier reliability might be influencing inventory decisions. The recommended action on that front is to review and optimize inventory management strategies and develop more responsive system to match supply with real-time demand. Fourthly, we to look at the relationship between the U.S. sales and the number of units. There is a positive correlation between U.S. sales and the number of outlets, suggests that increasing the number of outlets could potentially enhance sales. The recommended action is to strategize for expansion in location with high market potential and access to regional market saturation. Some of the challenges and limitations faced include the challenges faced during the data integration and normalization, particularly when combining diverse data sources with varying formats and scales. Limitation of the methodology also include potential biases in data collection and the constraints of correlation-based analysis, which does not imply causation. Furthermore, the analysis is limited by the historical nature of the data, which may not fully capture current market trends or emerging consumer behaviors. Future recommendation could include the incorporation of real-time data analytics to capture current market dynamics more accurately, and the business should continue to harness the power of business intelligence tools for ongoing decision making, focusing on predictive analytics to anticipate market trends and customer preference. As a conclusion, the insights from this analysis emphasizes the importance of a data-driven approach in decision making. Adopting the recommended strategies could lead to enhanced sales performance, improved customer satisfaction, and overall operational efficiency, thereby providing a competitive edge in the market. Again, my name is Jibril Anifowoshe, and thank you for joining me today.